This video will cover correlation and regression. We'll focus on an example where I can show you how to calculate, run hypothesis tests, and interpret for both correlation and regression. So we'll run through this example. An investment analyst collected data about 20 randomly chosen companies. The data consisted of the 52-week high stock prices, price-to-earnings ratios, we'll call the P&E, and the market value of the company. Given these data, we're attempting to predict and explain the market value using the 52-week high stock prices and the price-to-earnings ratio of the company. So to start with, let's calculate the correlation coefficients between each pair of the variables we're interested in studying. We're also going to test to determine if these correlations are statistically significant. For each pair of variables, then, we will conduct a t-test. The t-test operates in this fashion. We assume no correlation. In other words, we assume the correlation coefficient, the true value of that, this little guy here we call rho, is equal to 0, or a correlation does exist. In other words, that rho, our true population correlation, is probably something statistically different from 0. To think about correlation, it helps think about this on a number line. So if there is no correlation at all, we would be at 0, no correlation. This is theoretically possible, though it's highly unlikely to happen in practice. In the real world, we will typically get a correlation slightly away from 0, even if two things have absolutely no theoretical correlation at all. That happens because the variation in the one variable, in other words, how it wiggles around, looks a little bit like the variation in the other variable. Now, if we're in the minus 0.4 to 0.4 range, we typically say we have a weak correlation. If we're out here in the 0.8 to 1.0 range, at the minus end or at the positive end, we say we have a strong correlation. And if we're between those, we typically call that a moderate correlation. Now, this is how we categorize this in business. In other disciplines, you may find the categorization different. For example, in the field of psychology, humans are much less predictable than our business phenomenon. So you may find them adjust the standards here on what it means to be weak, moderate, and strong. To calculate correlations in Minitab, we will go to Stat, Basic Statistics, and then Correlation. So we'll select that option here. When the correlation dialog box comes up, we will just double-click our variables of interest into this variables box here. I'm actually interested in looking at all three of these variables and how those variables relate to each other. And then I want to click in this box here that says Graphs. I want to actually get this program to give me p-values. So I want to make sure this box is checked. And then I'm going to select the option here that says Correlations and p-values. We need to run the t-test. And instead of using a test statistic compared to a t-critical, I'm going to use the p-values to conduct our test. So hit OK again, and here is our output. The matrix plot that we have here gives us the variables 52-week high, P&E, market value, and P&E. Now you might wonder, why did it repeat P&E? Well, we need to be able to have 52-week high against both variables and market value against both of the other variables. And so we need to repeat P&E on the axis here to be able to get all of the combinations possible. Remember, we're attempting to discuss the correlation and to run the hypothesis test. So looking at our first combination, our correlation is 0.005, which actually is almost 0. So that looks to me to be not really correlated at all. It is approximately 0. And our p-value also is large. So if I assume an alpha of 5%, then I can say the P&E and the 52-week high is weakly correlated, or basically not correlated at all, And because that p-value is bigger than alpha, it's not a significant correlation. For the second combination here, our market value and our 52-week high, we have a correlation of 0.095. I would say that's still very weak because it's close to zero. It's less than 0.1, and that p-value again is big. So the market value and the 52-week high is also weakly, but not significantly correlated. Our third correlation that's possible here is the correlation between the market value and the P&E. You'll see the correlation coefficient here is 0.903. That's actually a quite strong correlation. That's the price to earnings ratio, seems to be highly correlated with the market value. You'll also see your p-value is really small. So for market value and P&E, we can say those are highly correlated and statistically significantly correlated with each other. So only for market value and P&E, that relationship between the two, can we reject the null hypothesis and accept the alternative. Now let's run through an example calculating a regression. Suppose we want to calculate the estimated regression equation for the impact that the 52-week high stock price and the price to earnings ratio has on the market value of the company. What we're doing when we run regression is really trying to generate an equation sort of like we learned back in algebra, a y equals mx plus b equation. I'm actually going to just rearrange the mx and the b terms. Remember, we're allowed to do that because of the commutative property. So y is some function of a constant plus a slope times x. The slope times x piece allows x to change, and that slope will tell us by how much y will then change in response. We actually have two x's here. We have the 52-week high stock price, and we have the price to earnings ratio. So our equation is going to look like this. We're attempting to predict or explain the market value. We're going to have a constant, which is a placeholder that tells us where the line sits in the xy plane, and then a slope times our variable 52 weeks high, plus another slope, a different value, times our price to earnings ratio. So let's let Minitab do the work for us here. In Minitab, to calculate a regression, you go to Stat, Regression, Regression, Fit regression model. I often say just keep clicking on regression until the word regression doesn't show up anymore. Once we've opened this dialog box, we want to put our y variable into the response. This is the variable we're attempting to explain or predict. For our example, we're attempting to explain or predict the market value, so that's our y variable. The two variables we believe are explaining this are our predictors. So our x's go in here. We double click in 52-week high and the price to earnings ratio. That's all that's necessary here, so we can click OK and we'll get our output. The output from regression has a number of sections in it. We're going to go through most of these in turn. So you'll see at the top something called regression equations, then coefficients, the model summary, and the analysis of variance. We were looking for regression initially to give us that regression equation. That's the first block there. So I'm drilling in here on it so you can see it better. That first block says regression equation, and it gives us this function. The market value of the firm equals minus 977. Now you might say, how could it have a minus 977 value? But remember, this is a placeholder for where that line sits in the XY plane. And our values for 52-week high and P&E are all positive values. So we're going to truly be only in this range up here of the line. So we have market value is negative 977 plus 11.2. That's really times whatever the value is for 52-week high plus 117.7 times whatever the P&E ratio is. So now let's interpret those coefficients. What do the 11.2 and the 117.7 mean? we don't interpret the constant. The constant is a placeholder for where the line sits in that XY plane. It's also used when we try to calculate a prediction, but we do not interpret that coefficient by itself. So what does this 11.2 mean, or how do we interpret that? Think about a slope that you did when you were in junior high or high school. This slope is supposed to tell you the change in y given a 1-unit change in x. So in other words, how much do we go up or down when x changes by 1? So let's put that in real world language here. For each additional dollar higher the 52-week high price is, in other words, when x changes by 1, the y value, the market value of the firm, will increase by $11.20. Now I know this is an increase because I have a positive sign here. If I had a negative sign, I would say when x goes up by 1, y goes down by whatever that value is. And now for the P&E, what does that 117.7 tell us? For each 1 point higher the price to earnings ratio, the market value of the firm will increase by 117.7. You may have figured that out already given our interpretation for the 11.2. Now we want to test to see if each of those x variables we've put in the equation have a significant impact on the y variable. We're still going to assume the 5% level of significance to conduct this test. Question we're trying to answer is, does the x really impact the y variable? Well, that would actually mean that we have a slope that is something other than 0. If the slope is 0, when x takes on different values, y doesn't change. So if our beta is 0, or approximately 0, there's no significant relationship between x and y. In other words, x can run around and do whatever it wants, and y won't change. However, if a relationship truly does exist between x and y, when we put in different values for x, the slope tells us how much y should be changing. So we should then, in this case, have a beta that's not 0. This kind of test is a t-test. This is a t-test with n minus k minus 1 degrees of freedom. You really only need to know this if you're going to do a test statistic compared to a critical value, but I always want to make sure you kind of have an idea of how this works. So this is a t-test where the test statistic is the sample value that we get for the slope minus the hypothesized value that we get for beta. Well, this hypothesized value is almost always 0. So really, this is little b, our sample slope, divided by the standard error for that slope. The computer will generate this test statistic for us, for those of you that like to do the t-score compared to the t-inverse. So we'll go back to our output here. We're going to drill in this time on the coefficients section of this output. So just focusing on the coefficients, you can see the t-values here in our Minitab output. I'm not going to use the t-values, but those of you that like that can do that. I'm going to focus on the p-values. So we're going to look right here. Our test is to try to see if beta is supposed to be something that's statistically 0 or something statistically far away from 0. By now you should be getting the idea that when the p-value is small, we can reject the null. So I can quickly look at these p-values and know what the answer is. For the 52-week high, since the p-value is greater than alpha, we cannot reject the null hypothesis. We cannot say the 52-week high price has a significant impact on the market value. However, the P&E value has a very, very small p-value, so small that it looks to be approximately 0. Since our p-value is small, we can reject the null. We can say that the price to earnings ratio does seem to have a significant impact on the market value. And in fact, because this coefficient is positive, we can say the price to earnings ratio seems to have a positive impact on the market value. We also want to be able to test the significance of the overall model. So we want to be able to see if this model actually explains for us the variation in the market value. This is an F-test, and I won't go into the test statistic here. We'll just let Minitab do the work for us. The null and alternative hypothesis look like this. The null says that beta 1 equals beta 2 equals 0. In other words, our two slopes, because we have two x's, our two slopes are both equal to 0. None of the variables then we put in the equation matter. The model is not significant. However, if we can reject the null, we know at least one of those betas is not 0. In other words, we know the model actually tells us some useful thing about the y variable. So if we're able to reject the null here, we say the model is significant. We're going to go to the analysis of variance section of the output. That's the bottom one that you can see on the screen. And let's look at that more closely. For those of you that like to use an F score compared to an F critical, you would use this 39.8 there. We're going to use the p-value. So this is the p-value we want to look at. The argument is the same every time when we have a p-value. Since the p-value is small, less than alpha, we can reject the null. We can say that our model is significant in explaining the market value. Other things we should be able to do. We should be able to use R-squared and adjusted R-squared effectively to explain the percent of the variation in the y variable that's explained by the x or x's we've included in the model. The R-squared and adjusted R-squared come out of a section called Model Summary. It's the third section on the screen. We'll drill into that more closely here. You'll see on this screen an R-squared adjusted, and an R-squared predicted. We are not going to use the R-squared predicted. We are going to use the R-squared and the R-squared adjusted, and here's a note on how to do that. Use the R-squared if there is only one x variable in your equation. Use R-squared adjusted, or what most people call the adjusted R-squared, if there are two or more x variables. We have two x variables, so we're going to have to use the R-squared adjusted. From this number, we're able to say that 80.33% of the differences, or the variation in market values across these firms, can be explained by the variables we've included in this model. Thank you for watching, and I'll see you again soon.